Hello everyone. Welcome to the second questions session of the second week of the course on Introduction to Modern Applications Development. These questions are for your practice. We hope you use them to understand the material that has been presented so far. There are about 10 of them, and we will go through each of them slowly. The first question. Consider the command line program in the first video session of the second week. From the moment it is presented on the command line, how many times is the command line information transferred from one point of the program to another before it is first used in processing? We have also given an answer to this. The answer is 2 times or 3 times if you also count do setup. The point is, in the first step it arrives at main via parameters, an array of strings called as args. Then it arrives at do setup as parameters, again an array of strings called args. Finally it arrives at process command line, again as an array of strings called args. Within process command line it gets used. For example, mode is args 0. Therefore the number of times it is from the moment it is presented on the command line to the point of its actual use, it is transferred twice or thrice if you consider do setup. Note that it would be useful to be explicit about how you count. For example, when you explicitly say a do setup when you explicitly count do setup, but also note that it may possibly be disagreeable to some, then it's a very positive thing. If on the other hand you just ignore it and don't write it, then it's possible that I may consider do setup as an important part and see that you have not counted it and therefore penalize. This kind of a thing occurs very much in practice between human beings. It is therefore useful to be explicit and clear about the way you answer things. If there are any assumptions, for example, if you assume that do setup should not be counted, then please explicitly say so. If you do not say so, there is no way one can be sure that you understand the way you count. Instead, it will just be a set of arguments. Unfortunately, we will not be able to give credit whenever it is just an issue of arguments. So please try to be as clear as possible whenever you answer questions. Let's look at the second question. Information to control program flow versus information to compute new values. This question is trying to distinguish between information that is used to control the flow of programs. For example, in process command line, the information on the command line arguments is used to decide should the program be doing registration, or should it be doing expenses, or should it be doing reporting. This is not about what to do. This is not about how to do. Instead, it is about what to do. So we will call such information as the what kind of a variable. In contrast, there are other pieces of information which actually generate new values. So for example, per head share in that compute fair share method, it generates new and useful information from whatever is available so far. Although they are variables which just remember information, we will call them as how variables, in the sense that they capture the sense of how to generate new information. This question asks you to classify variables in your programs as what variables and how variables. In the lectures, we saw a hierarchy of functionality of the command line version of our program. We are at question number 3. This was used as an example of good and bad practices of writing programs. But it is also useful to see the syntactic organization, or call graphs as it is also called, of our programs. A more complete syntactic view, or call graphs again, is when we have various calls arranged in a hierarchy as written in the source code. For your version of the command line program, write the following. When we say write, please do it by your hands. Do not use tools to generate that information that is asked. It is useful to, in the initial phases, to actually work out things by hand. The hierarchy of calls with well-specified list of parameters and return values. In addition to A, the set of variables that are read but not updated for each call. And finally, in addition to B, the set of variables that are also updated by each call. Question 4 requires you to list all the methods of remembering information in computing that you know of. It is possible that you might miss some. So try to visit your library, read books, recall from your memory whatever you have learned so far. Maybe even use Google or the internet to find out. But try to be as comprehensive and as complete as you can. Question number 5. What methods of remembering information outside of computing do you know? Apply the description techniques to each when you describe them. Make a brief note of how each works. The intent of this question is to help you see that the ideas that you have been using in computing are also actually around you. Next question. Our fair share program can be generalized in 2 directions as seen before. Answer the following now. First, list 2 generalization steps for each direction. Note that this gives us a total of 4 different generalization steps. Next question. For each of the 4 generalizations, classify the parameters as negligible, significant, and irrelevant, similar to the way we did for the fair share program in the video session. Questions of the kind of 6, in fact many of them that we have seen so far, are just trying to get you to look at your program and various parts of it in different ways. These ways could be useful for us as we progress through this course. We therefore urge you to try your best to answer these questions. For the command line version of this program, the database was a simple text file on the local disk. Suppose that this file is now required to be on a remote server. So it remains as a simple text file. It is a simple text file, except that it is not on the local disk but on some remote server. And your OS is not able to show network folders. In other words, although the file is on the remote server, on your operating system you don't have a program which shows you as if it's a local file. However, your system is able to do networking. It can do network operations, although it is not showing you in one single folder. In such a case, list the steps you need to take in order to A. Create a new database, and B. Initialize your program using a database from the remote server. It basically asks you to list out the steps you would need to implement create database and initialize from database in the source code. Question number 8. List as many differences as you can between a spreadsheet-based solution and a command line version. And question number 9. List as many similarities as you can between a spreadsheet-based solution and a command line version. Both these questions, in essence, actually just compare and contrast the two solutions with each other. There are some advantages of one solution over the other. There are some disadvantages of one solution over the other. Every approach really has both these aspects, the pros and the cons. And in practical life, we need to balance them. The last question. Our discussion of conversion between external representation of the information and internal representation appears very trivial. As in our command line discussion, the kind of conversions that we have done for input and for output appear to be very trivial. Even if we focus only on a single user, single computer, single program, etc., single, etc., style programs, it is still possible to see that such interconversions can be challenging. Our example may make it appear trivial, but that is perhaps because our example was not a very good one. But consider this. If you want to read an image file into your program, list out as many other examples, not the image file example obviously, as you can. Also, for each example, identify the reasons why it might make it challenging. Note that when you want to read an image file, you need to know the format of the image file. And depending on the way the format is organized, reading that file can become tedious. Thank you.